Hello. So today we're going to be looking at the T formula of solving trigonometric equations. So now let's start. So using the T formula, we're going to get three sets of formulae that we're going to use to solve trigonometric equations. And now this T formula is used to solve trigonometric equations in which we have the cos and the sine, and none of them is squared and none of them has a double angle, because in the previous chapter we've seen how to solve the trigonometric equations that involve a double angle. But now in this, for the T formula, we should have cos theta or sine theta terms. They are not squared and they don't have a double angle. Okay, now let's start. We're going to start with the T formula for cos theta. Now, starting with cos theta. So this cos theta is the same as cos theta out of 1. Now here you have to remember what we talked about in the half angle formula. In the half angle, from the half angle from the double angle formula, we said cos 2a is equals to cos squared a minus sine squared a. So if this is cos theta, you can have cos squared theta out of 2 minus sine squared theta out of 2 out of, now this one we can express it as cos squared theta out of 2 plus sine squared theta out of 2. Then here we can say divide through by cos squared theta out of 2. Now let me do that very fast. Okay, so now after dividing through by cos squared theta, this is what we get. So we get this is going to be equals to 1 minus tan squared theta out of 2 out of 1 plus tan squared theta out of 2. So this is cos theta. So we are going to let t be equals to tan theta out of 2. So we get cos theta is equals to 1 minus t squared out of 1 plus t squared. So this is the angle formula for cos theta in terms of the term. Now you can actually be asked to prove this as an independent question. So we are going to get a T formula for cos, T formula for sine, and the T formula for tan. And those are the equations we're going to be using. So now let's look at the T formula for cos. The T formula for sine theta. We're going to do this somehow faster. So sine theta is going to be equals to sine theta out of 1. And from the double angle formula, we said this would be 2 sine A cos A. So here, just going to say this is 2 sine theta out of 2 cos theta out of 2 out of cos squared theta out of 2 plus sine squared theta out of 2. So even here, I'm going to say divide through by cos squared theta out of 2. Now I'm going. Okay, so here we're going to have, this is going to be equals to 2 tan theta out of 2 out of 1 plus tan squared theta out of 2. This is sine theta. So still we're going to let t be equals to tan. Okay, so we have this. Now we're going to say sine theta is going to be 2t out of 1 plus t squared. This is the formula for sine. Then we can look at the t formula for tan. So the t formula for tan has two methods we can do it. So we can start by saying this is tan theta. By the half angle formula, this can be written as tan theta out of 2 plus theta out of 2. So what is this? This is tan theta out of 2 plus tan theta out of 2 over 1 minus tan theta out of 2 tan theta out of 2. So this is equals to 2 tan theta out of 2 out of 1 minus tan squared theta out of 2. So we let t be equals to tan theta out of 2. So eventually we say tan theta is equal to 2t out of 1 minus t squared. Okay, so another way someone would have done this, so this is actually a longer way. You would say tan theta, tan theta is equals to sine theta out of cos theta. And from the previous expressions, we saw that sine theta is going to be 2t out of 1 plus t squared. Cos theta is going to be 1 minus t squared out of 1 plus t squared. So here this is going to be 2t out of 1 plus t squared divided by 1 minus t squared out of 1 plus t squared. So this is going to be, we get the reciprocal, 1 plus t squared times 1 plus t squared out of 1 minus t squared. This would cancel, so here we get this is 2t out of 1 this is going to be 2t out of 1 minus t squared. This is the tan theta. Alright. Okay, now we're going to look at a summary of all of these. Right now we're going to look at examples, but before we look at examples, we should let's look at the summary of the t formulae. From what we've proved above there, we saw that cos theta is going to be 1 minus t squared out of 1 plus t squared. Sine theta is going to be 2t out of 1 plus t squared. Tan theta is going to be 2t out of 1 minus t squared. So this is a summary of the t formulae that we're going to use to solve trigonometric equations. Alright, so let's look at our first example in solving equations using the t formula. Alright, so we have this. So we said solving trigonometric equations using t formula, we should have either cos and a sine, and none of them should be squared, and double angle formula should not be applicable. Because for example here, if we had 3 cos 2 theta plus 4 sine theta, that question would be solved by using the double angle formula. You expand cos 2 theta, but now in this case you have cos and sine, none of them is squared, so we're going to use the t formula. Now since it's a first example, I'm going to quote, by the t formula, when t is equals to tan theta out of 2 cos theta, and we've proved how this comes about. Cos theta is 1 minus t squared, and this, and sine theta is equals to 2t out of 1 plus t squared. So we just substitute them into, now we have 3 cos theta plus 4 sine theta is equals to 1. So this is 3 into 1 minus t squared out of 1 plus t squared plus 4 into 2t out of 1 plus t squared is equals to 1. So you can have this is 1 minus t squared plus 4 into 2t, but since it's the same denominator, we can just write it like that. Then we would take this side or cross multiply, so this would be 3. I'm now opening this bracket, 3 minus 3t squared plus 8t. This is equals to 1 plus t squared. I take these terms this side, so what do I have? I have 4t squared minus 8t. Then I have 1 minus 3, that is minus 2, is equals to 0. So I can choose to divide through by 2. So what do I get? I get this is 2t squared minus 4t minus 1 is equals to 0. So now I solve for t. Remember I told you that there's always a working for solving the quadratic equation. So you don't just quote your final answer, you have to show that you're solving. So we solve for t, and how do we do that? We use can say using the quadratic formula, t is going to be equals to negative b. So let me just actually pause and because it's just taking time. Okay, so now we're here. So you see how we've solved the quadratic equation. So we solve the quadratic equation. Now we have t1 is this and t2 is this. So we can start working with maybe this, but remember t is tan theta out of 2. So t is tan theta out of 2. So now we can start solving this. So now we have this. So we start with when t is equals to 2.47. Sorry, this is 2.22. 2.2247. That means tan of theta out of 2 is also equal to 2.2247. So meaning this. So when we sorry, let me get this. So okay. So I was saying, so now when we have tan theta out of 2 is equals to 2.3. So I said theta out of 2 is equal to tan inverse of that. Now when I put into the calculator, this is the first angle I get. But remember the question is saying for angles between 0 and 360. So we can draw a quadrant here very fast. Something like this. 0, 90, 180, 270, and 360. Then here we put 65.8, 65.8, 65.8. This is 65.8. So all students take chemistry, and now for this you see the tan is positive, so we choose this quadrant and this quadrant. So this is the first angle, then the second angle would be this. So our second angle would be 180 plus 65.8. So we're going to have theta out of 2 being 65.8, comma 245.8. So theta is going to be 2 times 65.8, comma 245.8 times 2. So here I get theta is equals to 131.6, comma 491.6. So these are our two angles, but now this is already out because it's greater than 360. So now I can come and say how about when t is equals to negative that. So I come here and say about when t is equals to negative 0.2247. So here, but remember t is tan theta out of 2. So this is equals to negative this. So we'll say theta out of 2 is going to be the tan inverse of negative 0.2247. But remember, we said every time we have a negative, we first consider the positive, because putting the negative into the calculator is not going to give us the answer we want. So we have this, and theta out of 2, when you get from our calculator, is going to be 12.66 degrees. So I do the quadrant. This 0, 90, 180, 270, 360. So this is 12.66, 12.66, 12.66. This is 12.66, and all students take chemistry. And for this case, tan is negative, so it's this quadrant, and this quadrant we go here and we go here. So theta out of 2 actually is going to be 180 minus 12.66, comma 360 minus 12.66. So theta out of 2 is going to be 167.34 degrees, comma 347.34 degrees. So theta is going to be 2 times 167.34, comma 347.34 times 2. So what is theta? Our value of theta is now for this one, it's going to be above 180. So it's going to be above 360. So we want to consider it. We're just going to take the one we're going to get from this is going to be 334.68. So you can finally come and say theta is what we got at first, 131.6, comma 334.68 degrees. So this is how we solve our equation using the T formula. Now let's see. This example, we're going to apply the same concept, same exact concept. Just follow through patiently and you'll have the answer. So the value of x here is going to be 125.68 degrees and 340.6 degrees. These are going to be the answers. Still, this is also 4, 0. So you can try out that. Okay, so lastly, we are going to look at this as our last example for solving trigonometric equations using the T formula. So here we have 5 cos 3 theta plus 12 sin 3 theta is equals to 1. So note that here it's 3 theta, here it's 3 theta, here it's also 3 theta. And none of these is squared. So this question can be solved using the T formula, But if this question was 5 cos 6 theta plus 12 sin 3 theta is equals to 1. Now this question would have to be solved using the double angle formula. You expand this and say this is going to be 1 minus 2 sine squared 3 theta. Then you form your quadratic and you solve it like that. And now for this question, we're going to use the T formula. And I told you that when you're solving equations using the T formula, you just quote the formula. You don't have to prove the proofs. You just use them if asked. But otherwise, you just come and start. This is 2t, 1 plus t squared is equals to 1. Then you to remind yourself and also to show the examiner where t is equals to tan 3 theta out of 2. Why? Because this is 3. So I hope you see now. This is, so you do this, you simplify this equation, you solve it. It's going from a quadratic equation. You solve that quadratic equation. Make sure you are working for solving the quadratic equation because there are marks there. Then you're going to get maybe when t is equals to this and also t is equals to that. So now for each of these, you will say tan 3 theta out of 2 is equals to that. And then tan 3 theta out of 2 is equals to that. Then you now, so let me now pause and then do it, then you see. Okay, so now you see here we have, this is the same question. So here I formed the quadratic equation here. And now for me, I showed the method. I used the quadratic formula. I got T1 is this and T2 is this. Then now I went on further. Then did this, then these are the answers you get at the end. So that marks the end of the chapter on solving trigonometric equations using the T formula.